Hi class, in this short screencast I'm going to talk about the upcoming lab, which is separation of a mixture. Now, if this was a mixture like a sand and salt mixture and you had to separate the components, that would be pretty straightforward because you can just dissolve the sand and salt mixture in water, you can filter it. Sand will stay on the filter paper, salt would be dissolved in water, and you can just boil off the water later and you have the two components separated. In this case, however, you're going to work with a three-component mixture. One of the components is a neutral compound. One of the components is acidic in nature. And the third one is basic in nature. So just to give you a flavor for what those compounds are, the neutral compound is naphthalene. The acidic compound is benzoic acid. And the basic compound is para-amino ethyl benzoate. So I'm going to say, or ethyl para-amino benzoate. So EPAB is how I'm going to refer it for the entire discussion. This is naphthalene, and I have benzoic acid. Now, realize the example that I gave you, the sand-salt mixture. In that case, I took advantage of solubility of the salt in water as the principal point to separate the two components from each other, because sand is insoluble and salt is soluble in water. In this case, however, we are going to take advantage of the acidity and the basicity, and we are going to react the chemicals appropriately with an acid or a base to be able to separate the three from each other. So again, if you go with what's given in your lab book, the entire section on the instructions, you will go in circles round and round. So I would very strongly recommend use only the student handout for this and the instructions that I'm about to provide you. What I also recommend that you should do is that you should prepare for yourself a flow chart similar to what I'm about to draw for you. So get a schematic diagram as to what needs to be done. It really is a very simple lab, but if you don't label your glassware well, if you don't follow the instruction to the T, you can very quickly go in circles and lose track of what you're working with. So let's begin. What you're going to do is you're going to begin with a mixture of naphthalene, the ethyl para-aminobenzoate, and benzoic acid. All three of those have been mixed by us in a specific ratio, and you're going to take 2 grams of that mixture. Now the reason why I wrote this as 2 point number, meaning it's a number close to 2, you should know what that number is. It can range somewhere between 1.9-ish to about 2.1-ish or so, but you should know exactly what you're beginning with, because in the end you are going to report a percentage recovery of each of your components, and realize that all those three should add up to the 2 grams that you are beginning with. So it's in a specific ratio, like I said, but all of those should add up to the 2 grams. Now, you're going to dissolve the 2 grams of this mixture in 20 milliliters of dichloromethane. I would very strongly recommend this should be done in the hood. You should not inhale dichloromethane. So we're going to run this lab in the hood. The smell of naphthalene as well as the compounds is not something that you should inhale too much. So I would recommend that you should do the dichloromethane step, and anytime you're dealing with, or till the time you're dealing with naphthalene, you should perform that in the hood. So you would add 20 milliliters of dichloromethane, and all of this is going to be done in an Erlenmeyer flask. Erlenmeyer flask. And you will see that most of your mixture should dissolve at this point of time. If there are some pieces that don't dissolve, you can just use a glass rod to make it soluble, but for the most part, I think most of your material should dissolve. If you think that there is a big chunk which is not going anywhere, no matter how much you have swirled the Erlenmeyer flask, you can filter that particular component off. But you have to work with a clear solution of the mixture in 20 milliliters dichloromethane. All right? Okay. You're going to then add to this mixture, you're going to add 15 milliliters of sodium hydroxide. The sodium hydroxide that you're going to use is the 3 molar sodium hydroxide. So in the hood, you will see two different kinds of sodium hydroxide. One of them is a dilute sodium hydroxide. The other is a more concentrated sodium hydroxide. It's the dilute one that we are going to use. Please read the label very carefully. If you add too much, you have to start all over again. Okay. Realize what the sodium hydroxide is going to do. Sodium hydroxide is a base. So what do you think it's going to react with? Do you think it will react with a neutral compound, which is naphthalene, a basic compound, which is ethyl para-aminobenzoate, or benzoic acid? Obviously, you know from class that an acid reacts with a base. So you can hopefully envision that you have your benzoic acid, which is going to react with sodium hydroxide, and it's going to give you sodium benzoate and water. So sodium benzoate is similar to sodium chloride. That's a salt now. It's a polar compound. That would be soluble in water. So in this process, what have we done? Using this acid-base chemistry, we have essentially pulled the benzoic acid in its soluble salt form in the aqueous layer. So because you have dichloromethane and water, you're going to see that two layers would be formed, and you're going to transfer this entire mixture into the separatory funnel, which is a part of your distillation kit, by the way, and you guys are going to start checking in and checking out the distillation kits. So you're going to use a separatory funnel, put this entire mixture, the 35 milliliters concoction, which contains dichloromethane, contains sodium hydroxide, and contains your original mixture, all of that in the separatory funnel. You're going to then put the glass stopper on top and then go shake, shake, shake. As you shake, you obviously have to release the pressure. If you don't, you would feel that the glass stopper would want to, go through the champagne trick and probably would want to hit somebody. So make sure that when you release the pressure, you invert the separatory funnel and you release the nozzle. You will hear a tush sound for the release of the pressure, but shake that at least 3 to 4 times to make sure that you're giving both the layers enough interaction time and all of the benzoic acid is being pulled from the organic layer into the aqueous layer. When you allow the layers to settle down, you will see the dichloromethane layer and the water layer. So 2 layers would form. Now the question is, how do I know which one is which? So let's just call one A and the other B. Now if one asks you how can you distinguish between the two and tell which one is organic, which one is aqueous, how would you go about it? There's two ways to do this. You can look up the density, and of course the denser material is going to be the lower layer. Alternatively, you can take 2 test tubes and fill both of those with water. So put water. Take 2 drops from the lower layer and put it in the water. Take 2 drops with the top layer, put that in water. Whichever of the two, A or B, whichever is a water layer, essentially should be water and water. So you should see mixing. On the other hand, the one which is organic should either form a layer on top, or you will see it fall as globules at the bottom, depending on the density again. So that is something which you will be able to run. You have to give me the result of the test as to what was your observation, which of the layers is your organic layer, and which of the layers is your aqueous layer. You have to tell me that. But anyway, once you have that, you would separate these into 2 different flasks. One of the flasks you're going to just label basic aqueous layer, and the other you're going to call organic layer. Hopefully you can realize that the basic aqueous layer is going to contain the sodium salt of benzoic acid. So benzoic acid is present as sodium benzoate. That's what you have. And the organic layer is going to contain the remainder, so the naphthalene and the EPAB, which did not react with sodium hydroxide. They are now in the organic layer. You have to do this twice. The reason why you're doing it twice is because you want to make sure, you want to ensure that you have extracted out benzoic acid completely. So after the separation, you're going to drain the organic layer. You're going to collect that in a flask. You're going to put the basic layer separately, and then you're going to put the organic layer back into your separatory funnel, and then add another round of 15 milliliters 3 molar sodium hydroxide, and do the shake when trick one more time to make sure that you have extracted as much benzoic acid as possible. You can again separate the 2 layers out and mix the first basic aqueous layer with the second basic aqueous layer, and put those two, consolidate those two together. So now you have all of the base together. One of the partners should engage themselves in acidifying this basic layer while cooling. So cooling is a good option, good thing to do alongside as you acidify, because as you know, neutralization reactions are exothermic in nature. Your beaker is going to get heated up a little bit. Read that a lot. And so how do we acidify? That's the next thing. So you have 15 milliliters from round 1 plus 15 milliliters from round 2. Round 1 and 2 are for the extraction procedures, which are here. This contains sodium hydroxide and sodium benzoate. And we have to acidify that now. So we are going to acidify this with concentrated HCl with cooling. As you do that, make sure that you add drop-wise concentrated HCl. Make sure that you stir alongside. And as you stir, you will see that a white solid will precipitate and dissolve. It will continue to do so unless it gets to a point where it no longer dissolves and that white precipitate persists. White precipitate persists. If you check the pH, that should come out to be acidic at that time. And you can continue to cool it down to make sure that it's a complete crystallization. And then you're going to complete crystallization. And then you're going to basically filter it through a Buchner funnel the same way as you did last class. That's your filtration flask, vacuum. You're going to filter through, you're going to dry it. We will have the oven on, so you will dry it in the oven at about 100 degrees or so for about 10 minutes. So that will hopefully dry off all the moisture, and so you should be able to get it nice and dry, and you can then do a melting point for this. So what you're going to report is the melting point and the grams, so percentage recovery. Percentage recovery is what you're going to report. Realize the way you would figure out the percentage recovery is whatever grams you get divided by the 2 grams that you began with times 100. So this will give you a number. This number plus the percentage recovery for naphthalene plus the percentage recovery for the EPAB must add up to 100% to make the total 2 grams. What happens to the organic fraction? What do we do with that? That's the next thing. To the organic layer now, you're going to give it an acidic treatment. So you're going to add to that 15 milliliters of 3 molar HCl. The EPAB, which is the basic component, is going to react, and you're going to end up with the para-amino salt, ammonium salt, in the aqueous layer, and naphthalene, which is the neutral molecule, in the organic layer. Again, you're going to separate the 2 layers in your separatory funnel, so you should know which layer to collect. And you're going to separate that into aqueous, aqueous, and organic, and do this extraction twice. So when you have the organic layer, again, treat that with 15 milliliters of 3 molar HCl to make sure that you have completely removed your EPAB in its polar acidic form. So you consolidate your protonated EPAB in 2 steps. And then what you're going to do is basify this. After you have collected, then we are going to add a base. Which base would we add? We would add 20% sodium hydroxide. So that's very corrosive sodium hydroxide. Please make sure that you wear gloves at all times dealing with that. Again, you should cool it down first, and you should add with constant stirring. You should add till the pH is basic. So again, as you add sodium hydroxide, you will see that a white solid will appear and then disappear. You have to keep adding till it persists, and you will see that the pH at that point of time, the pH paper will show kind of like a blue color, like a teal color almost. You should cool it down, and then you should do the same thing what you did with benzoic acid. So you will filter it, and you will then find out the melting point of that. Finally, what do we do with the organic layer? The organic layer needs to be dried with calcium chloride. So we are going to add some calcium chloride, which is a desiccant. Recall from General Chemistry 1, desiccants are those salts which like to absorb moisture, absorb water. And so CaCl2 is one of them. And you're going to add approximately 1 to 2 grams of calcium chloride into this dichloromethane layer. Uh, you really need to, get a feel for this. As you add the desiccant, you will see that when you swirl, some of the solid will remain stuck at the bottom because it will become heavy as it absorbs the moisture, and some probably would move with the swirling action. Your aim is to saturate your system with calcium chloride because you want to make sure that there is absolutely no moisture remaining in your extracted material. So what you're going to do, and keep that as a rule for future as well. So what you're going to do is you're going to keep it for about 5 to 10 minutes. And if you see that there is some additional calcium chloride which does move with the movement, with the swirling motion, then that's good. If it's not there, then you probably have to add a little bit more to saturate the system with calcium chloride. And at that point of time, we will bring in a pre-weighed round bottom flask. So you must know the mass of that round bottom flask and record it in your observation table. You're going to then decant. When I use the word decant, that basically means that you're going to transfer only the liquid part, the solid will remain. You're going to decant it into the round bottom flask, and then you're going to queue up for the rotary evaporation and evaporate off the liquid. What will remain behind is your product. Let's take a look at the schematic of this step as well. And what you get, you're again going to take the mass of that, get your melting point, get your percent to. You're going to report 3% recoveries, 3 melting points for the 3 components. I'm about to draw the schematic for this step one more time as to what we are doing, but that's the procedure. So again, mixture is being dissolved in dichloromethane. You first basify it, you add sodium hydroxide, this is dilute sodium hydroxide. You collect benzoic acid in its deprotonated form in the aqueous layer. The basic and the neutral components, they remain in the organic layer. You do this step twice and you consolidate all the basic aqueous layers together. Then you're going to, one of the partners should work on the basification and isolation of pure benzoic acid. In order to do that, you will now add concentrated HCl to the system till pH is 7. You will cool it, you will filter it, you will dry it. This is basically oven drying. You're going to then take the melting point. You're going to figure out the grams on a watch glass and calculate the percentage recovery. To the organic layer, what you'll do is you will add now 15 milliliters HCl. HCl is going to react with the basic component to give you protonated EPAB. You're again going to do this step twice, basically because you want to make sure that you have isolated any and every piece of EPAB from that mixture. You then will basify the component because you want free EPAB, not in the protonated form. This particular one, however, cannot be oven dried and it has to be only air dried. I should also probably tell you that the filtration for this one it's a little bit slow, so it does take time. Be patient with it. As you have filtered, you will then dry it. You will find out the melting point, get the grams, figure out the percentage recovery. And the last bit is, what do you do with the organic component which is left over? So let's take a look at that as well. So you're going to simply add the desiccant, which is CaCl2, and the desiccant will absorb all moisture. So give it time, about 5 to 10 minutes. You will then decant it into a pre-weighed flask. Round bottom flask is what you're going to use. 100 milliliters is just fine, 50 or 100 milliliters. You will rotary evaporate. That means that the lab tech is actually going to work on that part with you. So you will have to provide your sample and stand in a queue, get your solvent removed from the system. So now you have only what remains behind in your round bottom flask is, as you remove the solvent, the solid stays behind, and that is after you have subjected that to rotary evaporation. And what you have remaining, you're going to take a mass of that. So mass of the final mass minus the initial mass of the round bottom flask, that should give you your mass of naphthalene. You will determine the melting point and also calculate the percentage recovery of this system. So what should your observation tables look like? Let's talk about that. You have to determine a bunch of things here in this case. So first you will begin with mass of the weighing paper. I do want to see that. Mass of mixture taken plus the weighing paper. And so the mass of mixture taken, this number is approximately equal to 2 grams. Approximately again. And then the first one that we recovered was benzoic acid. So you'll take the mass of the watch glass plus benzoic acid, and hence the benzoic acid by itself. You will then determine the melting point. So you will do it in at least duplicate, if not triplicate. Since you're working in groups of 2, if time permits, I would like to see 3. That's ideal, but at least 2, if not 3. And then you'll find out the average. Again, in order to get the average, you have to report it as a range, not low plus high divided by 2. But consolidate all the lows together, consolidate all the highs together, report it as a range. And then finally, you will also determine and show me the calculation for percentage recovery, which is item number 3 over here, the amount of benzoic acid that you got divided by the mass that you began with, times 100, and that will give you a percentage recovery. You're going to do the same thing for both your EPAB as well as naphthalene. So there will be one that will look like, let's change the color, maybe the EPAB recovered. So again, you will have a watch glass, you will have after acidification, you will get the melting point, get the average, get the percentage recovery for that as well. And finally, in case of the naphthalene, you won't have a watch glass, but rather, in case of naphthalene, you will have a round bottom flask. Naphthalene. So it will not be a watch glass, but rather a round bottom flask. So you say RB flask. But you still will have to provide me those numbers and a complete observation table. Naphthalene, and this should read naphthalene as well. And then you will do the melting points, determine the range, and determine the recovery. And the 3 recoveries put together should add up to 100%. So in the end, you would say percentage recovery 1, percentage recovery 2, plus percentage recovery 3. How much did you end up with? You have to record that, whether it's less than 100 or more than 100. That's immaterial, but you have to record that. So in your conclusion, you're going to say that the 3 components were isolated or not, as the case may be, and then you will talk about essentially the melting point and hence the purity as to how successful it was, and also talk about the percentage recovery. So if I were you, I would, in the conclusion section, compare all the melting point values to the true melting point of the benzoic acid, of the EPAB, and the naphthalene, so you can compare what kind of error you have gotten, and if that's acceptable or not. So you should discuss that in the conclusion section. So data table is not conclusion. That's just data table. You have to discuss that data somewhere. It is worth 3 points, so please do so. All right. I'll see you in class.